Thank you so much for attending today. Today we are going to learn from Ergest Xheblati. He is a SQL expert, data architect, and author of Minimum Viable SQL Patterns. I'm excited for this event specifically because I love learning from people that are just experts at their craft, and that's exactly who Ergest is. He's been practicing SQL for over 15 years, and today he's going to teach us about specific SQL patterns that he's learned over the years to go from really being a good SQL practitioner to a great SQL practitioner. Also, this event is brought to you by the Operational Analytics Club. So if you want to meet more SQL experts like Ergest, you can join the link right there, operationalanalytics.club, and I hope to see you there shortly. With no further ado, Ergest, the floor is yours. Thank you so much.
Thank you, Parker, for having me, and thank you for setting this up. Hello, everyone, wherever you are around the world. My name is Ergest Xheblati, and like Parker said, I worked in the data space for the past 15 plus years. I like to say that I'm fluent in English, Albanian, and SQL. It's my favorite language by far. I started my career as kind of a business analyst, where I was doing a variety of different things. But the moment that I ran into SQL and I started to learn SQL, I just fell in love with it, and to this day, it still remains my deepest passion. I've I've spent 15 years in the data space doing a combination of what you might call analytics engineering these days, what we used to call data engineering, or uh, business intelligence development. I've also done actual data analysis. I've done data science, a little bit of machine learning. So I've sort of run the gamut of all these different spaces in the data space. But I've found that what I enjoy the most is by far doing SQL development, and because of that, I noticed certain patterns that I was using over and over again when I was solving queries, and I was able to solve them a lot faster than someone starting from scratch. And so I realized there must be these sort of like Lego blocks, if you will, these patterns, these templates that allow you to solve problems really, really quickly. In here, you'll see that I published the book earlier this year in April of 2022. You can find the link to the book on bio.link/ergestx, or you can reach me on Twitter and you can see the link to the book there. And in this talk, I will cover just very few slides before I go into a live session where I show you a query that runs, that works really well, but it also is not very easy to read, easy to maintain. And so we'll go through and try to improve the readability of the query, hopefully even its performance. So I'll talk about why did I write the book, what are these patterns that I keep talking about, and what are some of the most common of these patterns. So why did I write these books? So as an engineer, or like as a computer programmer, software engineer, coming from kind of the world of engineering and going into the world of data, working directly with data analysts, people like yourself, I noticed, because I was reviewing their code and I was submitting it into our Git repo for our processes to kind of run the code automatically in the data warehouse. So the analysts, they knew their way around SQL. They could write very complex SQL queries that solved really complex problems, that created really complex models. But what I was more concerned with, what I started to notice, is that a lot of their code would be sometimes inefficient. It would take a really long time to run, or it would be really hard to read and understand. And I myself had to go in and kind of rewrite some of the code so I could understand what it was doing to make sure that it was doing the right thing. As I was reviewing a lot of this code, I noticed that it was really inefficient, repetitive, and even brittle. So if data were to change, um, the code would inevitably break. So I started to think about how do we solve these things in a manner that people can kind of reuse these patterns, these ideas. So what patterns are they basically they're templates for solving common problems. For example, if you need to dedupe your data a lot, um, you'll notice that after you do it manually the first time or the second time, you'll reach a point where you can just sort of, you know, exactly what that pattern looks like. You know that if you use, say, the row number with partition by, et cetera, like the window function, you can just copy paste that from your mind or from another piece of code and kind of reuse it in many future queries, and it becomes like a Lego block, right? Something that you use to solve problems in the future. And you can then sequence some of these patterns. Once you create them in your mind, you can sequence them to solve pretty much any problem. So if you need to dedupe data and then you need to create a very long table and then you need to pivot it out, you kind of know that the pattern is like, okay, I'm going to use this dedupe pattern, and then I'm going to use kind of this union all pattern, and then I'm going to use this pivoting pattern. So that's kind of the idea of like these are like bigger conceptual pieces to solve these problems. And so I sort of broke these patterns down into these four categories as I started to look into some of the code that I'd written, some of the code that other people had written. I noticed that they fell roughly in these four categories. Now, since I've published the book, you know, I've come up with a few others, and I hope to expand upon them and to kind of release another version of the book with more of these patterns. But for now, these are the ones that I initially wrote about in the book. So we have like how query composition patterns that help you compose, make your queries easier to read, easier to understand. Not necessarily more efficient, but definitely more maintainable. So an example of that is using CTEs as opposed to using subqueries, for example. Some query maintainability patterns. So the idea is that if a piece of code gets repeated multiple times, in software engineering, there's this DRY or dry term, which means don't repeat yourself. So if you notice yourself repeating the same chunk of code in multiple queries or even within the same query, that's a good example for applying one of these query maintainability patterns. And then there's query performance patterns. These differ a lot based on the system that you're working with. Different systems have different ways to optimize queries, both for speed and for like credit usage, etc. That's becoming more and more important these days when these cloud-based data warehouses charge you based on the credits that you spend on these queries. So there's like one of these patterns is like the concept of not ordering your data unless you really have to, or waiting to order the data until the very end. And finally are sort of my favorite query robustness patterns, and I call them defense against dirty data, just to give you a quick Harry Potter reference there. Okay, that's it with respect to the presentation. So we are going to quickly jump into a session. Okay, so what I'm showing here, and the details of this don't really matter. What's important here is that you get kind of the pattern, kind of see the query the way that I see it. So this is a query that uses Stack Overflow data to aggregate user level metrics at the user ID, username, and date level. So we have then things like questions that they created, answers they created, questions that they edited, answers that they edited, and so on and so forth. and we can run this query. This is running locally on my DuckDB database. By the way, I've been experimenting with DuckDB recently. I love it. It's great. This query only takes about about 10 seconds, and we get some data here. So this guy, Gordon Linoff, by the way, he is another SQL expert. He has written thousands upon thousands of answers on Stack Overflow, and he has a SQL book as well. So since we've ordered this data, we've sorted this data by the number of posts that were created, we see the person that has posted the most posts in here. Okay, just to show you that this query runs. Now let's kind of analyze the query from the perspective of some of the patterns that I mentioned here. So first of all, the first thing that I notice is the use of these nested subqueries. So we have one level of subquery here, and then we have another level of subquery here. This has 3 levels of nested subqueries. Now, there's nothing wrong with subqueries per se, but if you want to make your code easy to read and easy to understand, I don't like subqueries. I prefer to use CTEs. So why? What's wrong with these subqueries? Well, when I'm doing the select here, I'm using this activity type. Okay, well, where is activity type defined? Well, I have to go down to this level. Okay, it's not here. Then I have to go down to this level. Okay, so now I see where activity type is defined. Okay, so in order, now this is a very small query, as you can see, but imagine having like 300 lines of SQL that does this sort of thing, right? So you are trying to debug this query. So somebody else wrote it. You're trying to debug it. You go in and you say, what the heck, what is the meaning of this activity type? Before you even can read what it's doing, you have to drill all the way down to the level of the nested queries to figure out what activity type even is. And then you have to go back and then, okay, post type, is that defined anywhere? It's not. Okay, so maybe that's coming from, where's post type defined? Okay, so post type is defined over here in this level. So you can see how this is really, really hard. You go back and forth to try to understand this query. So that's the first thing that I notice. So if we scroll down a little bit, we see there's a union all, because the questions and the answers are in separate tables in this particular schema. And so the questions and the answers are sort of schema aligned. They've brought into the same column names basically, and they are unioned. But look at this. The same subquery that we saw up here is repeated again down here. Okay, that's an example of what I call, well, that's an example, that's an anti-pattern of the DRY, do not repeat yourself. If you make a change to this query here, maybe you had it wrong the first time around, you then have to go and change it everywhere else that this appears. And in a really, really long query, this is not a very long query, but in a really long query, you have to look, who knows how many search and replace things you might have to do in order to fix a single subquery like this. Okay, so that's the second thing that I noticed. The third thing that I'm noticing is this order by in here. What is that order by doing in there? We don't care about activity date. We're sorting by the number of posts created. So you might think, okay, well, this is not really doing anything, so it's fine if it's here. Well, it's not fine. Yes, your query engine might, do it really, really quickly, just like DuckDB does for me. But imagine if this was a really large table with hundreds of millions or billions of rows. Sorting is a very expensive activity. It takes a really long time it takes a lot of compute to actually be performed. And so data warehouse vendors are more than happy to do it for you, and they will charge you the appropriate number of credits based on how much data you scanned, or based on or based on the time that the query took to complete. So by doing, I like to call this like a premature sorting, right? Premature sorting means you don't really need sorting here, but when an analyst was developing this query, they started with this inside query first. They were like, okay, well, I can run this query and I can get me all the different post activity that happened in this post. Okay, now I need to add the user information, and so I do a little join here with users, and then they say, okay, now I need the other post types. I need the answers. So I can just union this, copy and paste all this code, and basically the query works. Everything is great. However, if I'm looking at this query, I say, okay, this query is unmaintainable and it's not efficient. Okay, so what can we do? How do we turn this query into something that's a little bit more efficient? Now I can try to do this live. Let's see if that will work. So the first thing that I notice is, let me take this piece of code and let me put it into a CTE here with CTE1 as something. Come on. Okay, so I'm going to copy this into CTE1. This again, this works really fine if I highlight it and I run it. And so now I've taken this repeatable piece of code and put it on top here as a CTE. I put a comma in here for the next CTE. The next piece that I'm noticing is that these two don't really need to be like this piece of code in here needs to be union with the other. So I can have another CTE here, CTE2. We take the question types and then we can paste in the answers. So we're basically, what we're doing is we're combining these two into a single CTE. Okay, so what we have now is we have, let's see if we can run this query. We cannot run it because this query was joining with this one up here. So do we want to join with that again? We can, but I like to delay the joins until the very, very end. So I'm going to remove these columns that depend on the join. And I'm going to basically try to run this. Okay, so now I get another CTE. Okay, so we have a CTE that gets us all the post activity. Then we have another CTE that gets us all the post types. Now I can get the final query up here and basically paste it in here and say, okay, this is from, doing this live, from CTE1, join CTE2 on CTE1.post ID equals CTE2.post. And then let's not forget our group by that we have down here. Let's get our group by and paste it over here. Let's hope that this works. No, as always, when you do things live, it doesn't work. Yeah, rather than try to debug this, I'm going to show you what it looks like. Okay, so here's the same query, but now it's what we call in software engineering, it's been refactored. Refactoring means you retain the same functionality that it was doing before, but you make the code easier to read or easier to understand or easier to maintain. So now when I'm reading this query, I say, okay, I'm defining a CTE called post activity, where I get one row per user per post, per activity date, right? And then I get the activity type, whether they created a post or edited the post. And then I'm adding another one. So if you think about this like a DAG, like a directed as acyclical graph, if you're familiar with DBT or Airflow, this is working like a DAG. We have a DAG with post activity, we have a DAG with post types, and then we combine them at the end over here. So the post types is just basically taking a post ID and basically adding a column for the post type based on where it's coming from. So the post questions has a question type, post answer has an answer type. Notice also that I removed the order by from this CTE up here. Okay, so that because I don't need the order by, and I'm saving myself both time and potentially money by not sorting the data before I really need to. Okay, so then I just have my final query that does all the aggregations that I really care about. So I pulled from post types, I joined the post activity, and by having these aliases PT, PA, now I know exactly where this data is coming from. So the activity type, I know that it came from the post activity, and then the uh, post type question answer, I know that it came from the post types CTE. So by naming my CTEs properly, by sort of like reducing, not only did I make the query easier to read, easier to understand, but also I very easy to maintain. If I come back here in the future, I know exactly what's going on. If I make a change to this post activity, I add another join, I add a filter condition. Let's say that I wanted to filter, where this creation date is between, which you can't type when you're typing live, 2021 09 1. Okay, and 2022 01 01. Right, that should, of course, doesn't work. Okay, I misspelled creation, of course. Okay, so now I should be able to run this query. Maybe the creation date. Oh, creation date is ambiguous. Okay, so I need to specify that it's the post history creation date. And now I can run it. All right, then when I run the whole thing, guess what? It runs even faster because now I'm pre-filtering data. So this is another pattern that I talk about in the book when it comes to query efficiency. You can very well take this creation date filtering and put it over here at the very end. However, in some cases, right, it's a lot better to put it next to the tables that you're filtering by. So it takes advantage of the indexes and all those other things that exist in tables. And this makes my query even faster. So yeah, so that's about it in terms of some of the patterns. I hope that wasn't too fast for the audience here, but yeah, happy to take any questions.
Awesome. Thank you very much, Ergis. We have received a couple questions in the Q&A. Okay. But everyone that's attending, add any questions you'd like on the right of your screen where it says Q&A, and then we'll bring them onto the screen. So Trevor Fox had a question.
Yeah, so
why
Trevor
join
has
BN performance or organization?
Yeah, I see the question. That's a good question, Trevor. So why am I joining here? Yeah, so right. So what I could have done is I could have taken these columns and brought them in here and joined with the post activity. And then in the final query, I could have just selected from the post types. It's neither performance nor organization. It's more of philosophical, like a philosophical, like software engineering term, where you want to make CTEs perform one thing and one thing only, and keep them very self-contained. So if you were to add columns to the post activity and then you wanted to bring them all the way down to your select, you'd have to change the post activity and the post types and the select. So you're kind of like you're repeating yourself, right? So you want to not repeat yourself. So if I can limit the scope of this CTE to just aggregating, to just getting me all the post types, and whatever else I need, I have it in a separate CTE. That makes it that makes it a lot easier to change in the future. Another thing that I will mention here is, if you notice that, like, if this piece of code, you keep using this everywhere in your queries, right? Because you, for whatever reason, you need to union these two tables, and everywhere that you go, you keep pasting the same CTE, pasting the same CTE, pasting the same CTE. That should be a trigger to you to say, wait a minute, so if I need to change this CTE, I have to change 15 different models. I have to go and change 15 different models by hand. So the moment that I see that I need to copy the same piece of logic somewhere, that's a trigger to say maybe this should live in its own model, in its own table or view, probably a view, because they are, there's already some tables. So I could take this, put it into a view, and then use the view in uh, all the downstream models, right? So this is I think the term in software engineering is like single purpose principle. I have to look it up, but the idea is that you want to contain the purpose of these CTEs to just the thing that you that you want, right? So um, if yeah, if I again, if I was adding columns to the top CTE or the middle CTE, I have to go and change it in all the different places. Okay, so I see another question in here from David. What are your suggestions for where and how to comment in SQL? I like to comment right above what I'm doing, so I would add a comment right there. Get the post types and combine them. Now, I'm a big fan of what I call self-documenting code. So I like to write these really long, if you notice here, answer to question ratio. Okay, so if you are reading my code, you don't need comments to understand what it's doing. So this is another, I guess you call it a pattern, but it's more of a principle that your code should be self-documenting, right? That makes it easy, not just for yourself, but also for other people. For example, I could have called these CTEs. A lot of people go CTE1, CTE2, CTE3. They solve the problem and they're done. They close the book on that query and forget all about it. 6 months later, if they're looking at the query, like, well, what the hell does CTE1 do? What the hell does CTE2 do? If you had taken the time and named them properly, you would then not have to answer that question. Okay, moving on to the next question. The group 1, 2, 3, 4, 5. How is this in terms of query optimization? If it's not optimal, 0 would optimize. So the group 1, 2, 3, 4, 5. This is more of a, has nothing to do with optimization. This is just a way to make it easier to make the queries be much shorter and easier. Otherwise, I would have had to. So if I didn't use the 1, 2, 3, 4, 5, I'd have to actually uh, group by all these columns one by one. So I have to group by that, group by that. I even have to group by this if I have to actually copy and paste this and do it like this. Otherwise, the query optimizer will complain if I didn't use 1, 2, 3, 4, 5. So this should technically work. Hopefully, I'm right. Okay, maybe I forgot something. Oh, okay, you can't use the as in here. Yeah, so this also works. Okay, well, anyways, like, I'm not gonna, okay, so there's another as. That's what happens when you do things live. Okay, so, but if you didn't do the 1, 2, 3, 4, 5, okay, so this also works. But look at that query. That is ugly and unmaintainable. I've copied and pasted code everywhere. If you did it, if you wrote your queries like this, I would probably not be very happy with you if I was the one reviewing your code. So doing 1, 2, 3, 4, 5 makes it a lot easier. Now, there's one thing to note about the group 1, 2, 3, 4, 5. This only works if your aggregate functions all come at the end. If there was another column in here, like if username was actually here and not up here, the 1, 2, 3 would not work. I'd have to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, and I have to say 1, 2, 9. Otherwise, this would not work. Okay, I'm doing this live, so I don't mind me doing that. But you get the point, right? So the idea is if you do aggregate functions, do them at the very end. Okay, so by doing the aggregate functions at the very end, you can do yourself a favor to do one group by 1, 2, 3, 4, 5, and so on. Okay, next question. I break down complex problems into smaller ones. Each smaller solution becomes a CTE or a subquery, and I find myself in a deeply nested CTE or subquery. I cannot help but feel that there's a better way to do it. Okay, so if you are finding yourself writing a lot of CTEs, like there's some, like for example, BigQuery will only allow a certain level of nested queries. After a while, it'll basically say, sorry, I can't run that code anymore, right? You've exceeded the limit of nested queries. So if you find yourself doing that a lot, that's a good it's a good idea to break your code into individual models. So if you're using a tool like dbt, then you take some of your code and turn it into, like, materialize it into a table upstream, or turn it into a view upstream, and then your downstream work becomes much less complex. So you're breaking it down in CTEs, but these CTEs then turn into tables or views, and they get materialized in the database itself. Um, Not always possible with unless you're using a tool like dbt or some other data transformation tool. But if you have that available to you, that's the best way to do it, is to go beyond CTEs and go into the realm of tables and views. Okay, next question. I have a habit of casting my date string to date types. Does the cast impact performance at all? Uh, of course, like every operation that we do here, casting will impact the performance a little bit. Although databases have gotten very good at doing this stuff really quickly these days. Where you might run into trouble is if your date is a string in the where clause, and you're doing the conversion from string to date in the where clause, and your date has like an index on the column. So when that happens, database query optimizers will tend to perform worse. So let's say that you have a date column in your table, and there's an index on that because it's like a timestamp, so it's like unique for every row. So it's really good to have this index. However, if you use a string and you don't cast it, sometimes and you basically call the call cast on a date, you can cause the index to not be used and make your query worse. So just the cast itself does not impact performance, but it might impact it further downstream when you're doing like filtering, like where clause or joins. Okay, next question. If you have a datetime column and you want to find the latest date, just date, could you cast max column as date perform better as max cast column date, or with the difference? Okay, I believe the difference there is negligible. The order of the functions, from what I've seen, doesn't really matter much. Query optimizers these days are really smart, so they will take either of those operations. They're identical to the query optimizer, and it will optimize them the same way. So basically, it will perform really well. So you shouldn't have to worry about whether you do cast max or max cast. One thing that I'll mention is if you're doing an aggregate query, cast max may not work. Your query optimizer might complain and say, "Hey, this column is not aggregated." So you then might have to swap like the aggregate function always has to go first. I tend to put the aggregate functions all the way out of the like the giant function chain, if you will, and all the conversion inside. So I prefer to do max cast as opposed to cast of max, because then I know that I'm doing a max, and whatever happens inside the max is more negligible. So performance wise, it's negligible, but from readability wise, and sometimes from query optimization wise, it makes more sense to have max cast. Next question. When do you decide to optimize the query versus the underlying table indexes? Always try to optimize the query first before you mess around with indexes. Indexes are um, I've had a debate with this with like data people. I believe indexing tables is a bit of an art and a science, but it's not an easy game to play or to learn. I've optimized a bunch of indexes in the past. They always warn you against having too many indexes. Too many indexes in a table can cause performance degradation. Too few indexes on a table can cause performance degradation. So I would go for optimizing as much as you can the query first before you tackle any index creation on the table. What I'll say there also is that the the so indexes work really well for columns that are used in the where clause or in the join condition, and columns that are very unique, something like a post ID or like a timestamp. If a column is like a categorical string that only has like 15 unique values, that's not a good idea for that to be an index. But like one thing to keep in mind with, especially if you have to deal with table indexes, um, like in Postgres or MySQL or SQL Server, when you're optimizing your query, one of the first things you should look for is functions that are used in the where clause. So if you are using like string concatenation functions or string substring functions, if you do any of that in the where clause, it will cause performance degradation. So you might want to take like if you're doing like a substring of name equals this, it's much better to use the like. So substring like this plus percent, which is the pattern for more, because the like is better for query optimizers than using functions in the where clause. Okay. Next question. You suggest avoiding using functions in the where clause, such as replacing date at yes with a hard-coded date. Have you used a date value variable that you can use in the where clause? Yes, I have. I have used date variables, and I'll tell you, query optimizers will still complain even if you use a date variable, because they're trying to predict what's the worst case scenario that could happen here. Now, of course, if you were saying like date equals variable name, that might work. But if you say something like date between variable one and variable two, the query optimizer might very well say, okay, worst case scenario, I'm scanning 50 years worth of data, so I'm just going to do a full table scan all the time. So I've dealt with this before, where I would declare the variable and set it to like a dynamically generated date, get date minus day 3, for example, and I would still get full table scans. So yeah, that's why I'm not a fan of putting functions in the where clause. Now, I've seen modern databases like Snowflake, DuckDB, BigQuery. They don't care. Everything is like a table scan, and they do it really, really fast because they have this massive compute. But me, having worked with like SQL Server for a really long time, I'm very sensitive to those things. Okay, next question from Joe. I don't understand the grouping in the CTE. If there's no aggregation in the CTE, is that different than sorting when you aren't aggregating? I don't understand the grouping in the CTE. If there is no aggregation in the CTE, is that different than sorting? I don't understand the question. Maybe you're referring to the post types where there's no aggregation. Is that different than sorting when you're not aggregating? The way I think about CTEs are like mini tables, right? Mini tables in memory. So you can do whatever you want inside a CTE. I just don't like sorting data in a CTE. I've seen cases where, sorry, my bad. Uh, let me undo what I just said. Yeah. So okay, so you can filter data in a CTE. That's really good. But if you sort data in a CTE, that's not good because you're causing additional computation to be used. So uh, that's yeah. I guess I'll move on to the next question. If you can rephrase the question, I can take another look at it. Okay, sorting is done in O of n log n time. Is it relatively cheap even on a very large? It's relatively cheap on a very large data set. Okay, um, you may be right about that, but I have seen cases where, say, you're doing a window function. Window functions always require sorting, and I have seen performance degradation, even if it is a few seconds or a few milliseconds. Yes, to the naked eye, it may not make a lot of a difference, But if you are, if I've sorted really large tables, and let me tell you, the performance degradation is noticeable. If you want a query to complete in a reasonable amount of time, so yeah, just take it into account would be my suggestion. Okay, I mentioned views. What is my take on a view versus an indexed view? So you can't really index a view, right? From the definition, right? So a view is basically a query that gets executed at runtime. So in order for the database to index a view, it has to materialize that view into a table dynamically in memory without you seeing it, and then sort of index it. So yes, it may perform better, but the materialization of the view will take sort of CPU cycles. My take on that is I, I want a view to be a view, and I want a table to be a table. I don't want to combine the two. Um, Next question. Is it a good idea if to add a sequential ID column that has no business meaning to large tables and add an index on the sequential ID? I've been told this is good for performance. um, so you might be referring to something that is known as like a surrogate key in data warehouses. So uh, these types of surrogate keys are used for joining data in the data warehouse much more efficiently. So, for example, if the business key is a string, by you creating a numerical index, you can make the performance better. So I lost the question. So yeah, so it's a known pattern that is used in some data warehouses. So doesn't always improve the performance of tables though. So it's not like you can magically improve performance by adding this index. It only works in cases when you're transforming data. You're taking your raw tables, you're adding an index, which then makes sense to that internal data set, right? Doesn't make any sense to the business, but the tables internally, they all know about the structure. So those will improve in performance, but you can't just add an index to any old table and have it improve the performance magically. Okay, next question. What is the performance readability different between using CTEs and temp tables? Um, it's a good question. So I think I used to solve problems with temp tables before. So I'm used to, like, the way in my mind it's sort of equivalent to solving the problem with CTEs. Uh, but in some databases, like we were working with BigQuery, and temp tables were not available at the time that we were working on it, so we had to use CTEs. Um, Temp tables are good because you can sort of materialize a result set in the disk. Now, okay, let me put it this way. Doing stuff in memory is always faster than doing it by dumping data in the disk. But if you dump really large data in memory and it doesn't fit, it's going to dump in the disk anyways. So I say, in my mind, they're equivalent, and you can solve the problem either way. Um, okay, clarify. In CTE 1, you are grouping, yes, but there's no aggregation in that CTE. Why am I grouping? Oh, I see what you mean. Okay, got it. All right, so the reason I'm doing a group by here is to dedupe. This is yeah, that's a nice catch there. Yes. So I'm not aggregating here, but I believe if I didn't do the group by, there would be multiple rows of the same. Um, yeah, this is a way of doing data deduplication. Yeah, that's the answer to that. Thank you for that. Thank you for catching that. Yes, that's purely for data deduplication. So just to kind of continue this, this is equivalent to you doing select distinct. Okay, so doing the group by and doing select distinct are equivalent. However, internally, the group by may be sometimes more efficient than the select distinct. I know people that, and by the way, this is another anti-pattern that I've noticed a lot. I know that people love to use distinct everywhere. That is just adding more and more computational complexity to your query. So I like to avoid select distinct unless I know that the underlying data is messy. Anyways, good question, Joe. Let's move on to the next one. Is it more efficient to do the group by in the first CTE versus using select distinct? I think so. Like I said, some like you could try it. It looks like in this database, it does not matter if I do select distinct or if I do go back and have the group by. Um, so you could try it and see which one is better. I prefer to get rid of duplicates as early as possible by using one of like a variety of different patterns, whether you use like a rank, like a row ID rank, whether you use like a distinct, whether you do like a group by. You can try it yourself and see which one works better. In like logically, they're equivalent. You're doing the same thing. You're basically reducing the number of rows that are being um, executed. Okay, Ankit, good question. Yeah, MySQL 5.7 does not support CTEs. Um, yeah, it's unfortunate. You have to stick to subqueries. There is no there is no other choice. However, I have noticed, like I was working with a MySQL database where switching from a join to a subquery, a correlated subquery, where you do something like where not exists, was a lot faster than doing the actual join. So yeah, unfortunately, you have to use subqueries. There's no, or tell the RT person to upgrade because MySQL 5.7 came out who knows when, 10 years ago. Just kidding. There could be a very old system that you can't really upgrade the database. So you're stuck. I'm sorry. Okay, next question. Speaking of optimization and readability, do you prefer some case when then one, or some case when then one, um, else zero and okay? For the readability, which one did I do? Yeah, I like to be explicit. Um, I like to be explicit because if you're not explicit, you don't know how it's going to handle nulls. Because what happens is when everything that it matches, it will sum the ones, but everything that it doesn't match, it will be null. So in some cases where you could use it like a count function, and then you can get rid of the zero. But uh, someone some case when then one end, I don't know. I prefer to say, okay, like you're saying, I could have inverted these, and this could have been a zero. This could have been a one. That's very confusing to me. anytime that you're inverting logic, it's super confusing, especially if you do like not true or something like that. Just say if it's true or if it's false. Like simplify your logic, simplify your make it easy for yourself. Okay, next question from Sam. I work with staging, DIMS, and fact tables. As the only data person at the company, I'm forced to join staging to DIMS in my CTEs. Uh-oh. Due to time pressure, bad practice. Should I do the data engineering first so I avoid using staging? Yes, you should. Absolutely, you should. One of the worst patterns that I've seen is people joining fact and dim tables to staging tables because either, like you said, there's pressure to deliver quickly, and they don't have enough resources to fix the code. I would much rather go and fix all the upstream tables to add the columns that I need. Now that could have repercussions later on. Many analysts don't want to do that, so you need basically help from data engineering. But if you're asking me, yes, absolutely, do the data engineering first and avoid using staging. If you continue that pattern and your company grows by 10x in number of people, you're going to have a hell of a time debugging models later on. You're gonna be dealing with this like I uh, I call this like the weed garden of data models. Right? There's just so many of them, and they're interlinked, interconnected. And I've seen this. I've seen this many times. Right? They're all interconnected, and so it makes it extremely difficult to debug anything. Like if you want to know where did this revenue field come from, you have to trace it through this like crazy, perhaps like self-referencing loops and DAGs and all these different things to go all the way to the source. Yeah, do yourself a favor and do the data engineering first if you can. Okay, for the creation date filter, instead of using date a hard coded date, can you use two variables for better readability? Um, Using variables like this has any performance on impact? Yes, you can. I answered a bit about variables earlier as well. Like the system that I was working with, which was BigQuery, did not support variables. And also, if you use DBT, it doesn't really support. I mean, I guess it does support variables if you use Jinja, but the raw SQL itself, unless you're doing like a stored procedure or a function, you can't really use variables in SQL itself. Sometimes you can. So, I mean, if you're determining the tables basically dynamically, and then you're running this query every day to go back a day, then yes, like you could use like a DBT variable that will automatically pre-fill that variable with that day's value each time, and so that will work. Will it impact performance? No, the performance impact will be minimal. Okay, next question from Daniel. I see the where true. I've heard arguments for and against this. Does it make difference in performance? No, it makes no difference on performance. It's only the only reason I use it, to be honest, is uh, so that, like, okay, let's say that I was saying like it's when I'm writing the query for the first time. So I could do, where true and some condition. So what I could do is I could like comment out that condition and rerun the query without worrying about it. Whereas if I didn't have the true and it was like this, if I comment this out and try to run the query, it'll fail. And then I have to like, oh crap, I gotta also comment out the where. So it's easy. It's only used to when you write the queries ahead of time. But it's one of my favorite ways to do it. I hope that answers the question. Okay, next question. When using joins, do you prefer join table or join select specific columns from table? I prefer join table. Doing the second one, so join select specific columns from table. Uh, nope, the former does not fetch all the columns. The joins are very efficient in database. The second one is a case of using a subquery. There are examples where you're like I said, when an older version of MySQL, you're limited to having to use subqueries, but um, yeah, I always use join table or join CTE. It's not going to fetch all the columns from the table. It's only going to fetch what you put on the select clause. Okay. Next question. I read it's bad practice to add sequential ID as a primary key where the database already has a surrogate key. Where can I learn about these practices? I don't know that there are any books on this, like other than like the Data Warehouse Toolkit by Ralph Kimball, which as of now it was the last edition was published in 2013, but people still use it. He recommends using these like sequential IDs as primary keys when the database already has a key. But he was the cases he was dealing with was when he had like limited space, limited storage, and limited compute. So he needed to make the queries very efficient. So he basically replaced strings with integers. All right, next question. Why did that disappear? Any tips for using CTEs in databases where they act as an optimization barrier? You're stuck, Tim. I don't think that there's any way around that. If it's an old MySQL, not unless you use some kind of like a translation, like a SQL transpiler that will take a CTE and turn it into like native MySQL code. DuckDB supports group by all, which what is my take on that? I'm used to group by 123. Most databases support group by 123. Don't use group by field 1, field 2, field 3. Like I said, if you're using any sort of calculations or case statements, you're gonna have to paste the whole damn thing in there. And I know I used to work with SQL 7, I believe, or 6.5, which did not have group by 123, and it was a nightmare. If your select was 20 lines, your group by would be an additional 20 lines. So group by all is new for DuckDB. I've only just started playing with it. I like it. I wish other databases supported it. What IDE am I using? This is dbeaver, dbeaver.io. It's free for everybody to use. dbeaver.io. Okay, how we're doing? I think we're a little bit over in time. How we're doing with time or questions, Parker? I know I kind of like ran through those questions at 100 miles an hour, but hopefully that was helpful for folks.
We're doing great. Yeah, thank you everybody for asking such great questions. Looks like there's one more right now that I'll pull up for you.
Temp tables versus CTEs. Is there any situation where they get locked up? Temp tables are unique to the session that you're in the moment. So if I run a query and I call it temp table 1, you'll run a query and you call it temp table 1, there will be no locking. Unless the database is performing some kind of like backup operation or some kind of restore operation where reading the tables is limited, you will be fine. I think that's it.
Perfect. Thank you so much, everybody, for attending and for being so engaged.
Yeah,
Ergis,
very good
thank you
questions.
so much for just being an expert in SQL as well.
Very good questions. I love answering SQL questions, and I am on the OA Slack group. So if you have additional questions, you can add me on Twitter and send me a DM. My DMs are open. You can ping me on the Operational Analytics Slack group. I will look at it and try to answer your question individually.
And there you'll see the link to join the Operational Analytics Club. You just go to the website, fill out the form there, and then you can meet a ton of data professionals like Ergis. And Ergis, before we sign off, do you want to pull up your slideshow so that people can see your Twitter and LinkedIn or whatever you were sharing with them?
Of course, of course. Thank you for mentioning that.
Mm-hmm.
Yes. So, yeah. So my Twitter is at ErgestX, and you can view all my sites. So, like, I have a Substack newsletter that I just launched. You can get a link to my book on that bio.link if you're interested. But I'm active on Twitter, LinkedIn, and a few Slack channels.
Amazing. Thank you again. And that is the end of the session.
Thank you very much,
Thank
Parker,
you,
for
everybody, for
setting this
attending.
up. I appreciate it.
Absolutely. Have a great day, everybody.
You too.